the lab, the type is super dead. Select field multiplier is 0. Click add new load. So this is the way how you can define the live load and the superimposed dead load. The next is earthquake load patterns. So for this you have to select the seismic load pattern and keep the seismic weight multiplier as 1, right? And then you have to select the desired code. Then you have to click on the modify load pattern and insert the data for the earthquake design. And then you have to take help from the UBC 97 in order to insert the data in the earthquake load pattern tables from the different tables defined in the UBC 97. So let us go to the E tab and we will write it here, for example, earthquake in X direction, and we will select as a seismic, and then the select multiplier 0 and select the auto load the code from the list as UBC 97. Click add new load. Again, write it as Y and add new. Right now we will move towards the different tabs. Click on the modify lateral load. It has different tabs. The first one is direction and eccentricity. We have to make this unchecked because it is only in X direction. So it is in only if you are designing only in X direction. So select only X. If you want to take the eccentricity effect, then you have to click on the X plus E, X direction minus E. It will take as 5%. The next would be the seismic coefficients, which you can, as per the code, and you can also define your own by inserting the CA in the acceleration and the velocity values, 0.4 or 0.6, whether the city is located. And as per the code, it will require the soil profile, whether it is SASBSD or seismic zone factor 0.25, 0.2, 0.3, or 0.4. The next is the time period, whether you want to use the method A, you insert the CT value, or you want to program calculate the time period for you, or you can insert your time period by manual calculation. And then you have to select the story range. You must select the base, and the top story should be the top of the building. And this is the factor, which is the response modification factor, or this is the importance factor. So let us have a tool from the code as well. The first one is the approximate time period. It can be calculated using earthquake equation given in the UBC 97 section 5.30.2.2, and this is the method A, which is the for the buildings. The T may be approximated from the following formula, and this is the formula. The T value is 0.35 for steel and 0.03 is for reinforced concrete moment frame percent. Because we are using FCPS, example pound foot units, so you will take this values in brackets. If you are using the millimeters and centimeter units, then you have to take these values. And 0.2 is for all building, for example, confined brick masonry or the brick masonry, you can use this value. So we will select method A, and we will insert the value of 0.03 for the reinforced concrete structure. The next one is the response modification factor, and this value can be selected from the table given in the building code of Pakistan or UBC 97, and I have explained earlier in the first module. In our case, it is moment resisting frame system, and for the special moment frame SMRF for the steel, the R value is 8.5. So we will take R value as 8.5. So it is already written. The next is the seismic coefficients. What is the soil profile type and the seismic zone factor? You already know. We are designing, for example, Peshawar is zone 2, so we have to select 0.2, and it will calculate all CACV itself. For example, if we change it this, so you can see the value has been changed. This is the soil profile defined in the UBC 97. That the CA is the hard rock, SB is the medium rock, SC is the very dense, and CD is the stiff soil. This value information you will get from the geotechnical investigation report, and you have to then assign this value in your ETAB model. This is another two types which is very rarely occurs. SE is a very poor soil, and SF is requires a special treatment before you design your structure over the soil type SF. So, what does the code says in exception when the soil properties are not known for sufficient details to determine the soil profile type? Generally, type SD shall be used. For example, if you haven't done any soil investigation report and you are designing your structure, you can take the value of your soil as a SD. So we haven't done any soil reports. We will take we haven't any soil reports. We will take SD as our soil profile. And seismic zone factor is 0.2 in for Bishop. We'll click OK. The first last thing is remain the importance factor. Let me go to the importance factor. So this is the seismic importance factor I, and it says different occupancies. For example, for the hospitals and for the emergency occupancies, the seismic importance factor is 1.25. And for all other genres, for example, residential buildings, commercial buildings, public buildings, it comes out in a special occupancy structure, and the seismic importance factor is 1. Right? So for the schools, for the residential buildings, apartments, commercials, you have to take the I factor as 1. And for the hospital emergencies, for the nuclear, for example, the nuclear facility structures, you have to take the importance factor as 1.25. So we have taken the importance factor as 1. Apply the changes in the y direction as well. Uncheck all of these. Use method A. This is 0. 8.5, this is 1, this is 0.2, and this is SD. Click OK. Now this has been defined. So we were talking about the seismic zone factors, that it's you already know that the seismic zone factor, the one is the Z value is 0.75, 2A is 0.15, and 2B is 0.2, for 3 is 0.3, and for seismic zone 4 it is 0.4. And these are the different zones of Pakistan's for the different cities, right? This is for the uh, Punjab, this is for Balochistan, this is Khyber Pakhtunkhwa, and you can see the Peshawar is in seismic zone 2B, which is 0.2, and this is the importance factor. Now defining the load pattern for the seismic zone 2 or less, for example, zone 1 and zone 2, it is very simple. But designing a building in seismic zone 3 and 4 is quite challenging. It requires additional information when you are defining your earthquake load pattern. What are these? So let us that you must have the fault information. For example, what is the NA, which is the near source factor, and what is NV, which what is the near source factor NV, right? And it depends upon the seismic source type ABC. What is ABC? ABC is actually the fault information and the maximum moment magnitude. For example, the maximum magnitude for the source has been recorded in the previous earthquakes is greater than equal to 7. Then it comes out in the category of seismic source type A, and then similarly for the B and the C. Right? So let me again go to the define load pattern. Let me show you modify. If I select seismic zone 4, you can see it says the near source factors. You can define NA and V, or you can say as per the code. Then you have to select seismic source type, whether it is ABC, and the distance to the source kilometer, which is given in here. You can see this is the distance you have to insert in the tab. So this was the whole story about the defining the load patterns. Let us move towards the load combinations. So you can add default load combination in the etabs by clicking on the default combos, and it will generate the combination. But we will define our own load combination as per the building code of Pakistan, because the UBC 97 has been removed from defining the or uh, creating the load combinations. Whether it is available in the defining the load patterns, but it's not available in the design categories. Let me show you. So click on the design, concrete frame design, revise preferences, and you can see there is a lot of uh, codes available. It is actually HCI, and there is no UBC 97 that you can design. You can, for example, the load combinations. So load combination will be defined on the code selected from the design preferences. So this is the load combination given in the code, and these are the different equations. And the F1 and F1 is 1 for the live load greater than the 100 psf, and the F1 is 0.5, and the live load is less than 100 psf. What is F1? F1 is actually the factor that is multiplied with the live load and the fourth combination of the code, fourth and fifth. 1.2D plus 1E plus into F1L plus F2SS is the snow load, and W is the wind load. So we don't have the wind load, we don't have the snow load, and there's also an exceptions in the load combination, that the factor load combination on this section shall be multiplied 1.1%, 1.1 for the concrete and masonry. It means that you have to increase the 10% seismic forces when you are using or designing your structure on the UBC 97. So this is the load combination that we have calculated after multiplication of the 1.1 factor with the load combination that consists of seismic force. For example, you do not have to multiply 1.1 factor with this because it has no seismic forces. You have to multiply with this because it has seismic forces. So these are the load combination. We will define this in our model. You can define default combos by selecting concrete frame. If you click OK, you can see it is defined the load combination as per the ACI, and ACI are taking these combination defined in the ASC 716 code or 722, whatever the edition is. We'll go to define load combination, add new combo, and that combination, the first combination is 1.4D, which is the dead load, and 1.4D, which is the dead load consists of the self weight plus the superimposed dead load 1.4D. So you have to select both self weight and the superimposed dead load. Click OK. Add new another combo. This is combo 2. Add dead load is 1.2, and this is the SDL, and the live load is 1.6. This is the second combo. The next is 1.2D plus 0.5L. Take the copy from this. This time it will become combo 3. 1.2D plus 0.5 die. Right? So this combination has been defined. Click OK. The next is 1.32D plus 1.1 earthquake plus 0.6 L. Well, take the copy, and this time is 1.32 dead, and the live load is 0.6, and the earthquake force is in x direction, that would be 1.1. Right, so this is the positive side, because there is in the combination you have to study this combination. If you still have any confusion, you can ask. The next one is the, because there's plus sign, so it will be only in the positive direction. So click take copy from this. So this time it will become combo 5, and you have to select only earthquake in y direction. Click OK. The next is 0.99d in the 1.1x and minus 1.1. This is actually minus in x, minus in y, plus in x, plus in y. Take a new combo and it will be 0.99d. And the only the earthquake forces that will be first time we will take is 1. We will take copy from this, it will become combo 7. We will make it minus 1. Okay, now we will take a copy from this to define in the y direction for the minus, and the copy from this take the plus for the y direction. So these are the total 9 combinations as per the UBC97. You cannot use the default combination for this model because you are using UBC97, so there will be compatibility issues and the results will not be correct. When you are using the new code, for example IBC, which has defined the code in ASC 7, then you can use the default load combination. And the load cases are automatically generated by the program for each load pattern. However, you can review or define your own load cases as well. Let's go to the define load cases. You can see that the load pattern that we have defined, it has generated the load cases automatically. So we will review this. For example, click on the modify, and you can see that the load case is linear, and there is no p delta, and the load name is dead, and the load type is load pattern. It is not an acceleration. Click OK. So you can define your own load case, add new load case. Whether you want to define a linear static, nonlinear static, response spectrum, time history, buckling, or another type of, you can use your own define. The next is the mass source is base shear is calculated by the equation given in the UBC 97, which is the equation 5.30-4. It is a factor CV and I into W divided by RT. RT is actually the fundamental time period. R is the response factor, and this is the coefficient for the base shear, and I is the importance factor, right? In the tab, you have to define the mass source in order to find the weight of the structure. So your tab will calculate the weight of the structure based on the structural properties and the load you have applied, and the R value is you have given, you have defined, it will calculate the T, you have defined I, and the CV value it will take from the different tables defined in the code, and it will calculate the base shear for you. In the mass source, only dead loads are to be used in calculation for the seismic weight. It is defined in the ASC 7 section 12.7.2. However, you can add 25% of the live load for the storage type of the structure. You can see this is the section. The effective seismic weight W of the structure should include the dead load as defined in the section. This is about the base, and other load above the base is listed below. So it is defined that only 25% of live load shall be calculated for the uh, structure that are used in the storage purpose. For example, warehouses, you can use this. So let us go to the E tab, to define mass source, and click on the modify. You can add your own, uh, and you can name it as, for example, base shear, not as a mass source. Uncheck this self-weight element mass, additional mass, click on the specify load patterns, and we will add dead loads only, which is includes the self-weight and superimpose dead. Check this include the lateral mass, and uncheck this include vertical mass. And it will lump lateral mass as truly. It means that it will calculate if you know the dynamics of structure, that the ETA will calculate the weight of the each story and will make it as a simple single degree of freedom system, and it will apply the forces at that story. Each story will be acting as a simple single degree of freedom system as a lumped lateral mass at each story level. Click OK. Now the mass source has been defined. So the now the structure, the ETA will calculate the base share of the structure based on the mass source you have defined. So this was the whole story for the module 5. So if you have any questions, you can ask.